Good morning, folks. So today what I'm going to be doing is going over the difference between two parameters. I'm actually going to make two separate instructional videos here. The first video is just going to be a brief overview of what's going to go on. And there's going to be two separate part twos and possibly part threes depending on the time. So I'm going to do one completely on the TI calculator. And then the other is going to be just on its own on the Google Sheets, because I did a little survey, and it looks like there's a good mix of those who are using both Google Sheets and a good mix of those using the downloaded app TI, or you're using an actual calculator. So just so I can optimize your time, this is how I want to go about it. If you have any questions, I'm always open for my office hours. Just log in, I'll help you out, or email me and I'll do the best I can. Okay, so today our objectives will be we're going to essentially compare two proportions or populations, depending on the situation. Now this, in my opinion, is probably the more important bit of hypothesis testing, because this is where really we can compare, does this actually affect change, whatever we're doing, or whatever we're comparing, is there a difference? Like, for example, one thing I did personally in my master's thesis, I compared an instructional method. I had I took a baseline test, a pre-test at the beginning of the course. I told my students, hey, we're going to be doing these supplementary instructions. We're going to see how you do at the end. We're going to compare. Everyone was on board. And then I ran the test. Then I had my test results at the end. And what I did is I took the average of the pre-test and the average of the post-test, and then used what I'm going to teach you today to see if there was truly, did what I did, my instructional methods, did that actually improve student instruction, student learning, yes or no? So that's the purpose of this, is it actually allows us to truly scientifically and statistically prove, is there a difference? And not only is there a difference, is there a significant difference, to explain why. So that's the goal of today. So we're going to do that, and it will also construct confidence intervals and go from there. Okay, so we must check all the requirements, because the requirements must remain the same as we go through each sample. Now the only thing different here is that we have to upgrade it to that, in the sense that we can't just look at one sample. Both samples or both proportions have to meet the requirements of the test. So for example, if we're doing looking at whether we're doing a z-test or a t-test, well, both samples must be over 30. Both samples must have population standard deviation. If those are not met, it's automatically going to be a t-test. If we have all of those, population standard deviation of both, sample size is both over 30 on both of them, then we can go to a two-sample z-test. But unless those conditions are met, we cannot do. We have to watch what we're doing. So please double check your samples. Make sure you know that they meet the requirements. And then I'm not going to go over the formulas per se. I'm going to have them on your formula charts because of the times. I'm not going to focus on that. I'm going to have the calculator do the work for you, and I want to focus on the interpretation. My goal will eventually be to be rereading articles towards the end of the year and determining, hey, when I read this article, does it make sense? Using a proportion, looking at their statistics and making a decision based off of those statistics. That's the most important portion of this course. I do recommend using p-value because of its complexity. If you're using a TI calculator, if you're using Google Sheets, we'll get there. We have a different story for y'all. Okay, so here are my examples. I'm going to stop the video here, and we will, like I said, discuss two separate videos. One for the TI calculator and another for the Google Sheets.